Whew, now that we have that figured out. Can you graph cosine? Emily, come up and tell us cosine.
Okay.
Don't forget to label your x's and your y's.
If you turn it sideways,
I'm so ready.
it's the same as that. This way.
Yes.
So it's like going up.
Yes.
My theorem.
All right. I even like labeling the x and y axis. That's even better. I'm trying to teach my 8th graders they need to label x and y. And I forget sometimes.
Can I do the inverse?
Yes, come on. Woo. As long as you're okay giving it in red right now. But should it be a straight line?
It's not a straight line. Look. It is not a
It
straight
should be more like
line. And I put a
curve
dot here.
and curve because here it's going to go back up. You can't do erase because now he's erasing. You're erasing his.
Oh, no,
Are you okay to erase? Let's make it small.
Can two people draw at the same time?
Yes, but 2 people can't erase at the same time.
Thank you. Okay, let's go back.
Let's go back to pen. Let me go back. Yeah, okay, there we go.
Wait, I forgot how we determined what the range, the range needed to be for cosine x, y. How do we do that? Oh, because if you don't, it won't be a one-to-one function. So it'd scoot from 0
0 to
to
pi.
Okay. So you really only need like 1/2 of it, right? Like
You only need half of a period. On either one, you're only going pi units. I'm debating on probably need to split that up, don't I?
No, don't you enjoy it? We're
I'm going to
enjoying
use
it.
it.
Are you enjoying it?
Oh, so
It actually was pretty like solid.
That was a good compliment. It wasn't the worst.
I mean, yesterday.
I think that's a great idea.
No.
I'm sure you play something.
Me? I used to be in the place.
I know you did.
I play guitar.
Domain and
And I sing a
range.
little.
Woo!
Dude, I can sing, just not well.
I think everyone can sing.
Wait, they're not supposed to be a straight line.
Nothing is a straight line. Every piece of it is a curve.
Me and Prince are not musicians.
A little bit more.
More?
No. More than what you have.
Wait, that's not right.
That is right. Correct. All right. I like the domain. We're inputting from 0 to pi, which is different than sine. Sine, we were going from negative pi over 2 to pi over 2. We're still going up and down to 1. So this over here was what you had to finish last night for homework. Did you get that?
Yes.
There's lots of just random dots. Who decided to just draw one right here?
Mr. Alfred likes to put a couple random dots and he erases them every
Wait.
Okay. So is the domain of our inverse the range of our function? Yes or no?
Yes.
Domain of our original function becomes the range of the inverse function. Okay? These are fill in the blank type questions that that there are some questions that are fill in the blank. Do I give you a word bank? Absolutely not.
Tricked us there. Thought you were gonna say absolutely, and you're like, not. Break our-
No.
It's like build us
So
up
the
and then break
domain
our
range
hopes and
is
dreams.
They just flip. They simply just flip. So the domain of the original, the range of the inverse.
Okay.
The range of the inverse of the original is the domain of the inverse. Why is that, Justin?
Because it's inverse.
Okay, when we, yesterday at the very beginning of class, we took points,
Yes.
and you helped. What did we do when we did the inverse? What did we do with those points? If it was 2, 1,
It was a reflection.
it was a reflection where across what?
The oblique axis.
No.
Y equals A.
Y equals X. All of our X's become Y's, and
What
all
is
the
that
Y's
called?
become X's. It's a line that's called Y equals X.
Oh, that's what the line.
That's what that line is called. So if we were to
I like oblique though.
So if I were to cut myself in the y equals x line, right?
that's not Y equals X, but that's okay.
You just said it was.
It's going the other direction. That's a negative. That's negative
Alright,
slope.
well,
So if we
maybe
go
I
this
missed.
direction, it would be positive slope. So we're going to go that direction.
And that way is negative.
That's correct.
Okay, I'm
Ryan
confused
is
now.
so good.
No. What are you confused
Ryan
about
is not.
No, not because of that. I'm just confused on my drawing.
on your drawing?
Yes.
All right, we've done sine. We've done cosine.
No way.
I want to do 10.
Are we going to do tangent?
That's the thing.
Oh.
Wait, will you explain the domain? I understand the all real numbers part, but what about the zero?
So we're going. What are we inputting? We cut it to go from 0 to pi over 2. So we restrict. Yes, we restricted our domain to make it a one-to-one function.
Yeah.
So then we have to put this
Oh, jeez.
x. Okay, and this is a less than or equal, not an e.
Sorry.
That's okay. So we restricted our domain, and then once we restrict our domain, everything else kind of goes along with it. Yes, ma'am.
I just don't get that graph. Does that make sense?
What do you not get about it? So over here we have a point, 0, 1. So that point, 0, 1, translates to 1, 0. Why? Because our x and our y's are flipped. Do you want me to put them together on one graph?
Can you?
I would love to. Are you ready?
Let's get ready.
How do you know which way the curve goes? Like if it goes down or up first? Because it's either sine or cosine. Like, okay, so you plotted your points, but then you go to draw the line.
Imagine
How
like
do you
you're
know?
drawing the full thing and think about what the full thing looks like.
But,
Like do like little dots. If you
yeah,
want.
no, I did.
Okay.
So I don't know which way the curve goes.
Okay, sine. Okay, let's do cosine start 0, 1. Okay, let's go over 1. I'm going to exaggerate a little bit more. Here's pi over 2, 0. So 0, 1, pi over 2, 0. And then going, skipping 1, 2, 3, 4 to get to pi, which, so cosine curve goes here. Where am I at? -1. Stop.
Is that time?
No, it is not.
What is it?
Cosine. Because Ryan has asked for them to be on the same curve. So cosine starts here, here, and then what would the cosine curve? It would continue to go back up. Okay. Now I'm going to draw a line that is y equals x. Is that good? Yes. Okay, so here we go. I'm going to label it y equals x. Here are my x's. Here are my y's. Here we go. In blue, we have y equals cosine x. Okay? Inverse function. Do you know what? If I want to reflect across y equals x, can I reflect this point? Where is it going? It's go into 1, 0.
Don't worry about it.
Why
Okay,
did
so
you reflect it over?
why would we reflect it over the y equals x line?
Because it's the inverse.
Because it's the inverse, and that's what we will always reflect across on the inverse function.
What is it?
Okay, so here the 0, 1 becomes 1, 0.
Oh, so they mean 0 pi.
So pi over 2, 0 becomes 0 pi over 2. So this point right here is reflected across the other way. Okay? Our last point, which became pi, oops, I didn't really want to do that in that color. Pi, -1. The inverse, I'm a long way away. I'm going to -1. -1, I went over 3 and up to pi.
Well, you went up for 4 for that one.
Because pi over 2, I went over 4 because it's a little bit farther than 1.
Oh,
Okay? I'm just making rows so they're not on the same point. So if I went at 4, I went 1, 2, 3, 4. This is pi. And then here's -1. Okay? If I were reflecting every single point throughout this, because how many points are really on this blue line?
An infinite amount.
An infinite amount of points. So if I reflected every single one, which would be kind of impossible, okay, then I would still go the same curve, and ultimately, when it goes through y equals x, you know what point that should be?
The same point.
When are they at the same point?
on the
Y equals x, where your input equals your output.
Oh, 45.
Generally, it should be, and it has to be 45 degrees or pi over 4. Okay? There will be a point where they're at that, where they are the same number. Okay? And then it's going to go here. Ultimately,
I know what you're saying. Like if you fold it
Yeah,
on the
you
line
fold
of
it.
YX, they don't match up.
Yes.
yeah, they do.
How?
Guaranteed.
You
Oh, I can't flip and fold my paper, my
They are
board.
the same shape. I mean, they are, but they aren't. Like, and part of
Okay.
it's already on the other side.
So if I flip this part right here,
How did you do this?
this part right here
Oh, it does
will be
match up
on
with that.
top of this part right here.
Oh.
Okay? And then, guess what? This part right here
Matches up with
will
that.
match up with that blue line on the
Okay.
bottom.
Oh my god.
This is my other question.
Okay,
It's like
so-
you
But do you recognize that this is going to
yes.
go on that? Yes? Okay, so that's, what is it?
So whenever you drew your 3 points, like you reflected them across the axis or whatever, how do you know which way to draw your curve? Like, do you draw it up or?
Because I'm going to go. What's a cosine curve? If you need to turn your paper sideways and draw a cosine curve,
But they look the same at some points. Sine and cosine. Like, just depending.
I know. Because every cosine curve is a sine curve, just with a phase shift. Okay, we're moving on to tangent.
No, Miss Evans, I don't think I can do it.
Yes, you can.
No.
No, it's not. Tangent's easier than either one that we've just done.
Really?
Yeah.
Okay.
Did we do it before? I see.
We have graphs.
Similar shape.
Sine, we have graphed sine, cosine, and tangent. We've actually graphed secant and cosecant.
Oh yeah, we did.
We
The
did.
ones that like they're parabolas that go up.
Oh, they have all the aspects.
Yes. Okay, so this is y equals tangent x. What do you know about tangent x at 0?
It's 0.
That whole
Okay. Do we need to figure out how you can know that? Okay, on the back of your plate, what does it say tangent is?
And it's sine over
Sine over
cosine.
Sine over cosine equals tangent. So I'm going to ask you a question.
See,
What is sine of 0?
sine of
Zero.
Is zero.
So sine of 0 is 0. What's cosine of 0? 1. So what's 0 divided by 1?
Zero.
I mean, zero.
Undefined.
1 divided by 0 is undefined, right?
Infinite.
Yeah, 0 divided by 1 is
Zero.
just 0.
Okay, so
Infinity.
let me ask my question again. What is 0 divided by 1?
0.
0. 0. 0. 0.
Wait. Hold on.
Why, Justin?
That is right, and I thought we said that, but I felt like I started guessing because I thought we did. That is right. I
Okay.
agree.
Alright, so 0. We're at 0. Now, where do we go from there? 45. Does anybody know what tan 45 is?
1.
There's 1. Really don't like that I put it right there. Pi over 4 is less than 1. I'm fixing to change something. I'm going to put pi over 4 not at a coordinate, not at a line. And I just wrote pi over 2. Sorry. Thank you. So what is negative pi over 4? What's tangent of negative pi over 4? Negative 1. Tan 45 is 1. Tan negative 45, which is in the fourth quadrant, is simply negative 1. Okay? Let's keep going. What is tangent of pi over 2? So let's go. What is sine pi over 2? Divided by cosine pi over 2. Looking at your graphs, what is sine pi over 2? 1. Cosine is pi over, what's cosine pi over 2? Tell me it's 0. So 1 divided by 0 is undefined. What do we put there in the math class?
Asymptote.
There's an asymptote. It can never equal that. If we went backwards,
It would be another asymptote.
negative pi over 2.
Is it tote or tote?
There's a P and then a T-O-T-E.
Asymptote.
Tote.
It sounds like a P.
Asymptote.
Alright, so what does this curve look like?
And it looks like a yeah.
It goes up, it goes down. Now I'm going to ask you a question. Is this the whole tangent graph?
No.
No.
It
What
does
happens?
it again.
It does it again and again and again and again on infinity. Okay.
Defined.
But with what we have graphed, one period of tangent, is it a function?
Yes. And it's a
Indeed.
1-to-1.
Is it a one-to-one function?
Indeed.
Indeed. So we don't have to restrict. We already
Anything.
have a restriction.
Oh my
So
God.
now I'm going to ask you,
Well,
what is the domain?
I have a
What is the
question.
range? Yes, what's your question?
So, like a graph line like that, how can it still considered a function? But like, doesn't it go up straight at some point?
No, it doesn't. Because if you plug in tangent in your calculator, tangent 89.99999,
So it's a
and if you
constant,
add just if you add another decimal with a 9 on it, it will be a completely different number. Or if you add a 0009, 0001, you will always get out a different number. It will never be straight up and down.
Oh, so that means when you're writing the domain, it's not going to be equals to, it's just going to be less than.
Oh,
Because it doesn't actually
so
touch
Tyler has already figured something out. Domain X is a set of all real numbers such that can we input? What is our domain? X's that we can go
Pi
between.
over 2.
Negative pi over
Negative
two.
pi over
Negative pi over
It's
2.
less than that.
Less than X. Why are we not putting the equal?
Because it can't
It
touch
doesn't
that.
It cannot and will never touch the pi over 2.
But it's not greater than pi over 2.
I put negative.
It's greater than negative pi over 2
Oh, it's less than pi over 2.
and less than positive pi over 2. What about the range? What?
all real numbers?
All real numbers.
All real numbers?
For the
There's no such that. Alright, because everything is coming out. Anything you want. Okay? Can somebody very quickly tell me the inverse y equals tan negative 1? I don't want the graph yet. Tell me the domain and range.
Oh, the
Wait. Dawn? I know, but I want it in hand. I don't want everybody screaming it out all at once.
You're not gonna call
Hi.
it yet.
Tyler has it.
The domain.
No, wait.
Oh wait.
Tyler does have it.
Oh my.
I want to
goodness.
know, do the
Miss
other
Evans.
8 of you,
Miss
7 of you,
Evans.
But don't you just
do you already know?
Yes, ma'am.
You do?
Yes, ma'am.
Yes. Justin, you got it?
Yes, because I
Tyler
flipped it.
enlighten us.
Alright,
So I know
Tyler.
it.
Tyler can
Give me the domain of the inverse
I don't know
function.
if I want to give it to you.
He's really normal.
Well, the domain's all real numbers. And said range would be the y's is all real numbers such that negative pi over 2 is less than y, which is less than pi over dose.
I completely agree. Now, what would that
Wait, is your
Me.
y negative?
Would it just be going off?
Y negative? No.
if what it's either one. You want that, it doesn't matter.
You don't need to put both.
No. No, you don't.
Really?
Okay, so could I graph? So what my y is happening, so if there's asymptotes along my y, will there be asymptotes at
Yeah.
pi over 2 going this way?
Don't you just flip it? Like 1 times 1 times.
Mm-hmm. And when we go down here, negative pi over 2.
That is a lot easier.
But this point is going where? At pi over 4, 1 becomes 1 pi over 4. Okay? So it's going to go like this, up there, like this, down here. Not really exactly drawn a scale. Sorry. Imagine that.
If you had drawn it,
It would be perfect.
You're right.
All right, we did tangent today. Getting a little bit more in depth.